Okay. So friends, we are starting our first meeting. So we are going to review hands-on machine learning with Scikit-Learning, Keras, and TensorFlow. Uh, this is if you don't know me, my name is Vikas Kearney. I'm a architect. I have more than 20 years experience in the industry. Aditya, you want to give your introduction?
Yeah. So currently I'm working as a software engineer, having 7 year experience in Microsoft technologies and .NET, Angular. So this is all about me.
Awesome. Nivedita, you want to give your introduction?
Yeah, sure. Um, so hi everyone. First, this is my first meeting with Vikas, and it's really my pleasure to meet you guys, and good chance to talk about myself. Thank you for getting me some time, and so I have a master degree in data science from DePaul University, so where I developed a strong foundation in statistical analysis and machine learning. And over the past 6 years, I have worked in various industries, something like finance and in energy sectors. So my recent position as a data scientist at Bank of America. So I worked in many predictive analytics models, as because is showing the book, the predictive analytics book on machine learning. So I am pretty aware of that book, and I have read that. I was telling because, yeah. So that's kind of like a brief overview. Like I do that, and apart from that, um, I have many hobbies. Like I do painting, and I try to spend most of my time with my little ones, and so much learning from them. Yeah, thank you.
Awesome. Awesome. Welcome, Nivedita, to our group. So let me share my screen. Hmm, It has been some time. Do you guys remember how to share the screen on Zoom?
In the down below, there is a middle button, green color button named share.
Share. Oh, okay. I have to. Okay, okay. Share the screen. Thank you, Nivedita. I'm. So you guys can see my screen, the machine learning landscape.
Can
Okay, so let's start our journey, the first chapter. First one, I really like the introduction. In the introduction, he talks about the example. He gives a very good example, and we will use this example throughout our review. He talks about that machine learning. It has been there for years, and best example is spam filter in the email. If I don't know, you guys remember like about 10 years back, how many junk emails one used to get. We used to get all kind of junk emails. And now, based on machine learning, these spam filters are so advanced. Hardly like in my Hotmail, Gmail, I hardly get any spam email. It is able to find all the fake emails. It looks like it is based on what are the emails being flagged as junk as a junk, and so it is working perfectly. And to be honestly, I miss my junk emails. I weekends that I'm getting bored, so I'll say, okay, let's check my email, and there's no email, and I feel very bored. So what do you guys think about machine learning and emailing system? You have any thoughts? Nivedita, you want to talk anything? Email.
Y- Yeah, I mean, what you were saying, I don't want to go deep, but that is one of the examples of the machine learning model. So the machine learning model is actually divided by two parts. One is supervised and another is unsupervised. In like layman term, so supervised also divided in two part. It's like a tree, two part. One is regression.
We'll come to that, Nivedita, a little bit later. As a general, I want to talk about email.
Yeah, so spam filter, yeah, it is one
Do you
of.
miss your spam emails in your
Yeah,
inbox?
I made some rule in my email that the spam directly goes to the spam filter, and like something like job related emails, like if something like marketing emails, that goes to another filter. So automatically that I did to my email. Actually, we can do that. Yeah, this is one of the best, good, and it's one of the appropriate examples. Oh, my daughter is up.
What do you think, Aditya, about emails? Do you miss your spam emails?
Yeah, spam emails I receive like I have won a lottery regarding $2 million or something.
Uh, to start today, I had a lighter joke. The best spam email I got, which I believed is true, I was working on a project and I was having very hard time debugging issue. I got a spam email that my uncle has died in UK, which I did not know, and has left me $1 million. And I wish my uncle was there. Left me 1,000, 3 million pounds so I can quit the job and live happily ever after. Did you ever guys fell for any spam email, any fake emails, spam scam? Recently, my friend told his father, his LG refrigerator broke, and he googled, and he fake website came, and he ended up calling them and sending them like 50,000 rupees in India, and he lost that money. So do you have seen some anything scam which is very interesting, Nivedita? Nivedita, any
Yeah. Sorry. Yeah, so what happened? One of the examples, like 2 years back after my graduation, I was interviewing. Like couple of interviews I did. In a week, around three, four, in the last 2, 3 weeks, I gave around 10 interviews. So I got one email, like random email from something at the some recruiter at the rate that consulting.com, that you have been selected, and let's talk about the best salary, and we will compensate all the like traveling. I was ready to travel, actually. Traveling details are below. Then it was kind of very genuine. Then in out of no earth, why shouldn't I believe? Like, because I was actively interviewing, I already did. Then I thought, okay, it's maybe one of the companies, HR. Then I replied them, thank you so much, and let's have communication going forward, and like to decide the salary and everything. And he also replied me back, like, that's great, awesome, and let's do the what time we were. Then I said, okay, I'm in Chicago, this is the time, and this time to this time I am okay. Then he said, okay. Then after that, he's gone. Like, I kept on typing like something like, when can we meet? Okay. Then I didn't get any reply, nothing. Then I took that email and put it in like Google and see like it's completely spam. I was really shocked, like someone is searching job and I am like end of my OPT period, and they are doing this with me. This is one of the best examples.
Aditya, have you fell for any spam email, spam scam, email scam? You're mute, Aditya.
Yeah, There's so much scam, and one scam for me. I got new credit card, so maybe they knew that I have made a credit card, so they sent me an email regarding we are extending your credit card limit. So you have to just share your one OTP details, and we will extend your credit card limit. So I got scammed.
Cool, cool, cool. So let's go to what is machine learning? The machine learning, I really like that two examples. First example, he says, machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. And second, he gives very engineering. A computer program is set to learn from experience E with respect to some task T and some performance measure. If performance on task T as measured by P improves the experience E. So Nivedita, do you remember this engineering definition? You have read, you have heard this machine learning engineering definition?
Yeah, they are they are very straightforward actually.
Uh-huh.
Um, the first one, system that learn from data to improve performance to on a task. It's the simple example like we give when we were school. So it shows like input, there is a machine, there is a output. So it's that same example. You are just feeding the machine something and you will get the result, the wonderful results. And that result says how to improve, um, how to do something without doing anything. That's a machine that automate everything. That's what it says. And the input is always data. And the second one, useful when problems are too complex for explicit programming. That's what I said, it automated and helps in dynamic environments and tasks difficult to hand code. So automation means we usually do continuous and without manual effort, right? That's the dynamic environment. And no need to do the hand code every time, it automates. That's the three lines usually says. That's what a machine does.
That's right, very true. Nivedita, you really nailed it down. So basically, he gives a very good example of email system. Writing a spam filter is very, very difficult. Means always the people who are sending spams, they are changing. They are changing the words. So it's very difficult to build that complex set which finds out every time. Because once you write the program, they're gonna use new keywords. And as you said, machine learning is very good for this task where it is very complex. The rules keep changing, and so this is a very good use case where uh, of machine learning, you machines are learning based on the data. You don't have to write the code to make sure that new scenarios are handled. And so machine learning is very good. Another example he gives about is speech recognition. We have different accents. Means there are so many versions of English, and no way you can program to recognize speech. So another machine learning, another area where machine learning shines is finding out machine this language speech recognition patterns. So that's another very good use cases. And then that's what he says. Problems where existing solutions requires a lot of fine tuning or long list of rules, and complex problems for which traditional yields no good solution, and fluctuating environment. And so also it helps us to get insights from the complex problems and large volume of data. So very good examples he gives is that spam filter and another voice recognition, and there has been some like uh, finding some patterns for the cancer where machine learning is very good. Go through huge data, find out some patterns to diagnose cancers. So what are your favorite examples in machine learning, Nivedita?
Um, so favorite, like I'm very acquainted with the fraud things. Like I worked in bank, so whether a transaction is fraud or not fraud, that is the universal for me for last 2 3 years. So I have been working like different models in machine learning. So based on the user, like what type of transaction is doing, sometimes the legit transaction consider illegit. Like you did a transaction for some reason, your transaction failed, and you get a notification that your transaction failed, but the bank sees it's maybe it's fraud. So that's one of the best examples, like spam or not spam. This is fraud or not fraud. It's a similar, and they are in falling in the similar category.
I was like Nivedita, I was very impressed. I was using a Discover credit card, and I was moving my house. I called some movers, and they that time like I did not have too much money. Means I was new in America, and I was like, okay, I paid so much money to the movers, and I didn't know I have to tip these workers also handsomely. So I gave minimum tip, and they were upset. And so I gave them all the credit card information. In the evening, Nivedita, like I got a call that your credit card there has been scam on your credit card. Your credit card is being cancelled. We are sending you a new credit card. So my guess is some people who were not happy, they had the credit card information and they used it. And how smart is their system? Immediately, first transaction, it found out that fraud is happening. Beautiful.
Yeah, I mean, even not even the bank never allows the flash transaction also. Like it's now so advanced.
So advanced.
Yep.
Beautiful. 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 So here we comes to an interesting topics like type of machine learning system. As Nivedita was already explaining, there are supervised. Let's move to. So these are the examples: spam filters, recommendation systems. I really loved Amazon recommended systems. I was amazed. Like that was like long time back, like 10, 15 years back. They were early pioneers of recommendation system. You buy a book, and they will recommend so many good books. I guess they would. I never liked Netflix recommendations. Netflix recommendation. I watch a movie. It's getting better, but initially it was really bad. It will show me movies which were no related to my interest. But Amazon, you buy a book, and it was able to recommend you books, and that voice assistant, and um, uh, so Nivedita, you want to add anything? As you added, you went to fraud and you told fraud. So here comes machine learning, supervised versus unsupervised learning, and Karan is also joining. Hi, Karan. We started, and yeah, Karan, can you hear me? So welcome, Karan, to the meeting. And so supervised and instance versus model-based learning. So Nivedita, you want to talk about supervised, unsupervised here?
Yeah, very quick. I'll not go so deep, just one line. So as I said, like when machine learning always divided between two parts, supervised, unsupervised. And supervised means you will feed the system everything. Like for your example, the spam filter. For the spam filter, you are feeding the machine the number of emails, the sender, and receiver, time, everything. And you are asking the machine, tell me whether it's spam or not spam. The output is always spam or not spam. That's called supervised. And unsupervised, you are giving a lot of details to the system. and you are saying, I don't know anything. Please make them one group. That's called unsupervised, like Nepal, like in USA. Um, you have to the you are feeding the system the many data and say say how many Indians are there, how many Americans are there, how many Africans there. So they will cluster those data. That's called unsupervised. So there is not like fraud, not fraud, spam, not spam. He's not doing anything. He's making the group. That's called unsupervised learning. The second one is kind of like batch versus online learning.
Before we batch, Nivedita, there are some more. There is a semi-supervised.
Yeah, semi-supervised, it works like both supervised and non-supervised because of the data. Like data is so like insufficient to work as like supervised, and data is not too big as cluster them or group them, the unsupervised. That's called semi-supervised. But here you have to work a lot to decide and need expert to see what to do, whether we have data to work on this. That's why the semi-supervised comes.
And there's another self-supervised learning system. Are
Yeah,
you aware of that?
yeah. So that's the system really wants to work, but system doesn't. It's like a baby. The system doesn't know how to do, how to work. So you have to give a chocolate a penalty. If you don't this, I will give you penalty.
That is reinforcement model learning,
Yeah,
reinforcement
so
learning.
reinforcement and say self one, it's kind of like a little bit similar.
Okay,
The algorithm is different, but it's kind of same. Self,
okay.
yeah.
That's what self-supervised. He gives a very good example, like you, you feed some picture of cats, and you want to fix the image. And at the end of when the model runs, it knows how to define different pets. Is it a cat? It is a dog,
Mm,
and so basically, it's labeling, it's classifying.
mm,
And at the once you went from unsupervised, you can use it as supervised.
mm,
And then reinforcement model, I think DeepSeek,
mm,
a lot of these LLM models are using. As you said, it's a based on agent,
mm,
and you it's a reward or punishment.
yeah,
So you reward it if does the right thing. You punish it if it does the wrong thing.
yeah, right. That's reinforcement. Um, but the self one little bit confused. Let me check. They
It's
forget.
okay, okay. No,
Yeah.
no. So yeah, self is like means it's learning and classified labeling kind of. It nicely says. A lot of people says that self self is like unsupervising, but he says no. It is so unsupervising is, as Navidata said, is about clustering. You have information. Some people are reading your blogs, and you want to see 90% 90% are male, 10% are females. That is more unsupervised. And yeah, that's good. So batch versus online learning. And Nivedita, you want to come talk about batch versus online?
I'm still going through like what there are online.
Sure, sure. So I'll carry you do your reading. I'll carry on the conversation.
Yep, yep, yep.
So so batch is like batch processing is all or nothing. You feed all the data to your system. Like I think that's what ChatGPT did. They fed for a couple of months all the internet data to their model. So that is batch, and so that's I don't know. They have improved since then. It used to take a lot of time for them to run this model because they have to run all or nothing. So that's the problem with the batch that it can go obsolete. If you remember, ChatGPT used to give some messages initially when their model was new, that they ran the model 3 months back or 7 months back, so they don't have latest information. Over the time now, they have improved some. They can do some internet searching and give you latest information. So it has improved. Um, so. Online learning is basically you keep learning. The system, as new data points come, and your system is still learning. Instance based and versus model based learning. Instance based is basically email. You just tell, okay, this is a sample. I got this junk email. If sometimes something again this kind of email comes, that it's a junk email. Model based learning. So this is the best part. Navidata, you want to talk about model based learning?
Um, oh, 1 second.
Sure, sure.
I was just going through the what Google is saying.
Mm-hmm.
Model-based learning involves creating and using an internal mental model of a system to organize information, make prediction and plan action rather than relying solely on direct trial and stored examples. So what it means, like we have a set of data like other already stored in a database, and we are fetching it to the machine. Instead of doing that, is using an internal mental model, and that usually recognize the patterns. That's what it says. But in a real case, in real scenarios, only supervised and unsupervised and reinforcement we are using. Those are the like examples and like parts of the machine learning, but nobody usually actually uses that in the real world. So there the definition we have to memorize. That's why. Mhm.
Agree. So another model-based learning.
Yeah.
Uh, so I think this is the most must be mostly widely used. It's a model-based learning. So in basically model-based learning, you build a model. It gives examples. So like suppose you can download the data like for different countries, what is their GDP and what is their life satisfaction. So you will see some kind of pattern. It's more linear pattern, and as you can see, more the country's GDP is high, the more people are happy. So there is a two parameters here. Means what is the GDP and what is the GDP, and based on that two parameters you can calculate. Uh, Based on this country, this GDP, how happy they will be. So you can calculate based on this one. So like I used to work for a healthcare company, and this is building a model based pattern. Model based is very common. I think use of machine learning. I used to work for a healthcare company, and we have data from a lot of hospitals. So it's like a lot of hospitals they join together to form a consortium, and we have data from all these companies. And so based on this data, we could build a model. Okay, this patient, how long he is going to be in hospital, what is the cost? So like some pregnancy generally, if there's no complication, you may be in the hospital for 2 weeks, and that's a common thing, and you would know what are the costs would come if it is not Caesar operation. So the cost would be very less if it is normal delivery, no Caesar operation. And so but if somebody is suffering from disease, if it is severe cancer, it's last stage, his chances of surviving is less, procedure will be more, you calculate the cost. So this way hospitals could predict how much they are spending the money, and they used to most of these are Medicare and Medicaid. So government pays for to this hospital lump sum. Okay, you are handling 100 pregnancies, you will get this money. So they have to make sure they don't waste money. So they build this model, and more data, more accurate is the model. And so that's what, like every year, we have some statisticians who will come, understand this data, build model, and then they will validate the model. So it takes some, okay, this patient had this disease and he came to hospital. Was his length of stay was same, but the model predicted, and they find out whether model is right. I think that as we learn more, we will be learning more about these models. Some are linear, some are log, all those things. All this will come into later picture. In fact, I went to a airline first thing. I went to airline interview, and these people were supporting a system which calculated the price of the ticket. Generally means before going that interview, you would think some person must be deciding the price, based on some intuitions. He must be thinking, okay, just what is the gas, who's the market, and he will come up some price. But I was shocked to see again they were very data driven. They have a model to figure out what the price should be. There was a huge teams which were managing that. So yeah, Nivedita, you want to talk about a little bit about model based learning?
No, because actually I'm good. It's not in my mind now what is model based. Like they are very pretty similar, model based and the regular ones. So I have to go
In
through.
the fraud in your fraud system, you had some models
Yeah,
your data and oh, okay.
we usually have many classification models, and I in my past experiences I always use regression and classification. Never worked in this type of models.
Oh, you cluster and regression, Ashar, not on linear log. Okay.
Yeah. So mostly their classification and regression, sorry, classification supervised and unsupervised, mostly used in the company. But there's model based, and those are the like key terms we usually knew here. There are only and just the logic we don't use that much. But yeah, reinforcement we always use neural networks. Those are on demand now.
Beautiful. Karan, have you used any models in any other company? Statistical models, Karan? Can you?
Just for AI, you mean?
What's that?
AI?
Not AI, just a statistical model. If I think me and you were in Talwar.
Oh,
Another example, yeah.
like
Another
repository, you mean the repository pattern and all that stuff?
no. Data,
Data.
mathematics.
Okay, data. I think I've just done mostly. No, I don't do too much database design right now,
Great.
actually. But
Yeah,
I
Karan, like,
mostly.
come, let me talk. Like, you and me me and Karan, we used to work for a company, Talwar. I maybe I should not take the name. So they were more into Internet of Things, and we had a tanks where we used to supply some gases, and these tanks means there's a usage, right? There's a usage, regular usage, like fraud. You are spending regular money, and fraud detects some unusual spending by you that it's a fraud. Same way in the tank, these fuel tanks, there's a certain usage happening. If there's some leakage, they want to know, oh, leakage has happened. So that is called anomaly. So that's another very good artificial intelligence use is that finding out something wrong has happened. Some leakage is in the tank, so we need to fix. It's not the normal usage. The levels are getting down very big kind of thing. So that's another example I have seen where like anomaly based, where you online you're trying to find, oh, some things were good, something really something abnormal has happened.
Yeah, so in AI, it's called anomaly detection. So in every model, we usually use that term.
So main challenges in machine learning. So basically, I really liked some means what are the data issues means actually why machine learning has become so powerful because we have huge data. So like it gives example like our eye means if you have to train a kid, oh, this is apple, you just show him apple and okay, he got it. But machine, you have to feed him millions pictures of apple to tell it's apple. Because for machine, some task which is easy for humans is very difficult for machine to like understanding apple. You have to feed lot of images to machine so that it knows if this is apple, this is banana, this is things. So one thing is if you don't have good data, insufficient data, that's the problem. Non-representative data. It gives an example of a election, like 1929, 1913. The election was held, and a company sent kind of they send what you call surveys to million people, so a lot of people, 100,000 people, and they came okay that Republican candidate will win. They were very sure. But what happened? Democrat win, and they found out all the people whom they sent surveys were the people who were listed in some telephone directory, they part of some libraries, and those were very most of the well-off rich people who vote for Republican anyway. So there was a bias, their data was bad, and that's what there could be noises in your data, there could be errors, outliers. Outliers means some people were very rich, they may vote differently than the people who are earning regular salaries. For them, inflation could be high. So if you are surveying very top, if you're feeding data to machine which is not normal, as we said in diseases, you can have some complicated issues, and your length of stay could be very huge. Your cost could be huge, and if you're feeding that outlier data to machine, it's not going to work. Irrelevant features. So yeah, Nivedita, you want to talk about data issues? Yeah.
Um, yeah, I mean those are on my on the screen. Those are the main data issues. But like bias, you said that's a big challenge in the machine learning model. So bias usually happens when your machine sees an apple, your machine sees an apple, an orange, and banana, and all of a sudden you are getting a watermelon and say get like what is that? How can a machine learn? Okay, so that happens when machine did never seen a new data. That's when an overfitting or bias, like overfitting or underfitting bias or variance happens, and that's because of the true limit data and maybe true limit and data quality is not good. A lot of noise, error, outliers. You said outliers is always like the fast, fast, less than minimum and greater than maximum. So like in a company, um, in company-wide valuation or feedback times, usually say, okay, get the feedback from the employee or the regular employee. But outliers are those are like very in the top, like CEO, CTO. Those are like outliers, and the minimum outliers those are entry level people. They don't know anything about the company, and they just joined. And if you are taking review from feedback from those guys, and what will they tell? And if you are asking a CEO of the company, you give the feedback. How does a CEO knows what a regular employee does in the
You
company?
know,
We are spending 8 9 hours over there. We are working hard, and he doesn't know who is this employee, how much hours he is working. So those are kind of outliers. So we don't consider those people in the data feed. So data should be very quality. If the quality is less, then you will see noise and errors in the model, and model doesn't read them properly.
good.
So that's how you mentioned over here. Another is irrelevant features. That's a good one. I missed it. So irrelevant feature like in the company example, the feature is like whether the employee have spouse or children. What to do with the spouse and children in the data feed? So data should be employee, employee's age, and employee salary, and that says the feedback. If you add the employee spouse, number of children, that doesn't help. So they are the irrelevant feature. So you just have to remove them by asking the subject matter expert.
Beautiful. And that logarithms, like logarithm issues, overfitting. So like it's like the real scenarios could be very complex. As Nivedita said, we trained our model, our machine learning logarithm to just apple or oranges and bananas, and just suddenly you give watermelon. So that's what like our logarithm is very general. It doesn't know something new comes and it cannot comprehend watermelon. Over that's overfitting. Like things are too complex. Like another example gives. We go to some country and that taxi driver charges us extra, and we say, "Oh, that country is full of cheat." That's overgeneralization. So that's another example of overfitting. And underfitting is means like too simple. Your model is too like linear. I love the linear model, Nivedita. It's very simple. That's the easiest straight line. But as life is too complex, that straight line is not good enough for most of the scenarios. So
Mm.
that's logarithm issues. That's another debate. Does the logarithm matters? It's like, is data more important or logarithm more important? Nivedita.
Data is more important
Data.
always. Logic can be studied, can be read through
Yes.
books, and you can implement. Anybody can implement. But if you
Uh,
don't have quality data, then never works. It's never
yeah.
gonna work.
Yeah. TikTok, they are trying to find out the mechanism, right? How it works. Because if they are trying to find the logarithm, right? In
Mm.
TikTok, that's but that's their recipes, right? It's for some companies,
Companies.
their logarithm. So testing and validation. So testing again is like software testing. Whatever I was reading, he says have a training data and test data. Find out, make sure in supervised. Of course, you will. That's what training and test data. You will cross validate, and validation set for model selection should be there. Basically, that's what we for model selection in when I was in the healthcare industry. As I said, they used to calculate a model to calculate the length of stay in a hospital for a patient, his cost for all his procedures. Once they build a logarithm, they used to run real life examples, which has happened in the past. Like, okay, this model is calculating correct or not, and some kind of variation is okay. How much variation is okay? So that is called validation. So how, Anurita, how do you validate your machine learning in fraud? Uh,
Mm. Yeah, that comes under the cross validation. So there are many ways actually. In layman term, I can say like you have a full data, you got a big data, and so first we usually split them, the 80% data in the train and the 20% in the test. So we train the model, we usually show the model, see this is the train data, and how you work on the test data. If the model builds well, then it can generalizes well in the test data. Otherwise, it cannot find the patterns. This is totally new, right? And the validation usually happens in the same way. So that train test, split, train test, another like in bank usually three splits. Here train test, validation, out of time. Four types also usually do. But the cross validation, like there are k-fold cross validation um, and I mean there are many actually fast in, fast out cross validation. There are many. So we don't actually, because those are the thing usually done automatically. Also, there is a algorithm called extreme gradient boosting algorithm. It's kind of tricky. XGBoost it's called, and that algorithm does everything by itself, like feature selection itself, splitting, cross validation, performance, everything by itself. So we usually use that. That's kind of little tough. But yeah, cross validation by manually usually do by k-fold cross validation, min max. There are many ways. Um,
Awesome. Nivedita, thanks for joining us. I think we are at the end of, let me see, any data mismatch and practical issues and summary, machine learning from data,
mm,
not hard-coded rules, different machine types with different tasks, data quality and representative matters, balance overfitting versus underfitting, and testing validation. So that concludes our meeting. So uh, I want your feedback. How's our meeting go? I'm thinking that the next chapter is very complex. I would recommend it's a hands-on exercise. I would recommend everybody to take it seriously and try it out. It will give us whole. We'll understand more. We'll get more benefited. And very thanks to Nivedita for joining us. We got some great insights from an expert. So Aditya, how you feel this meeting once in a month is a good thing?
Yeah, we can plan accordingly.
Okay, okay.
Yeah,
Karan, yeah,
really
yeah,
thanks to
Phil.
you and Nivedita for this nice session.
Karan, what are your thoughts?
Yeah, I think
How
once a month is good, or maybe we can do once every 3 weeks or something like that, so that we can do that also. So this book you are reading, is there a link you said? Is there a link for it?
Yeah, the means let's talk offline.
Okay, but if we can put the link
Is
on
there?
the
Is there?
chat
Is
also.
is there? Is
Yeah.
in well, let's talk offline.
Okay.
Nivita, how did you feel the meeting? And is it
oh,
okay once in a month or 3 weeks?
yeah, for me, I really enjoyed this session. Like as it's in my background, in my area, so I really enjoyed. Maybe if it's a different book, like developing Java or C, maybe if I don't find anything similarity, I will get bored easily. But that's what happens if somebody from different field and putting them in my field. I totally understand, but I really liked it. About the occurrence, I don't mind joining twice in a month or one time in a month. I don't mind.
Beautiful. Thank
Um,
you.
yeah, and thanks for having me here. I really
Thank you.
loved it.
Thank you very much. Okay, guys, have the nice weekend. And this timing is good for everyone?
Mhm.
For me,
Yeah,
it's
for me it's good.
Yes.
Also,
Yeah.
Nivita is very good. Okay, guys. Thank you very
Thank
much.
you.
Have enjoy your Sunday. Bye bye.
All right. Thank you.
thank you.
Thanks for
Good day.